You distribute through, we have 4 sine squared theta minus 1 inside. I know this has been long. We're almost there. So we have cosine theta equals 0 or sine squared theta equals 1/4. So over here, when you take the square root, you get sine theta equals plus or minus 1/2. So first of all, let's talk about this. What are all of the theta values where cosine theta is equal to 0? So pi halves plus pi times n, where n is any integer, right? Or sine of theta is equal to 1/2. Sine is the height. Where is it equal to 1/2? Pi over 6. I'm going to take this. Pi over 6 plus 2 pi n. Or how about negative pi over 6 plus 2 pi? No, what am I doing? That's wrong. Oh no, that would be right for the negative. That's what I was saying. Negative pi over 6 plus 2 pi n, because that's where sine theta is equal to negative 1/2. Or 5 pi over 6 plus 2 pi n. Or 7 pi over 6 plus 2 pi n. Right? Right?
Yes.
Okay. Now, I know, right? Bear with me for just a little bit. Looking at these, we would have to verify that the denominators were not also equal to 0. Because if so, we'd have to cancel those ones out. I also could kind of see, just based on them giving me the graph of this, do you see how when theta is equal to pi over 2, the only places I could be would be like up there or down here, and 3 pi over 2 would be the same? So that's out. So it sure seems like the pi over 6 or 5 pi over 6 or 7 pi over 6 or 11 pi over 6, also known as negative pi over 6, are all possible values. Gosh, what do I do here? Let's plug in pi over 6 and let's see what we have. So 4 pi over 6. My r squared is equal to cosine of 2 theta r squared equals cosine of pi over 3, which is equal to what? At pi over 3, 1/2. So then when you take the square root of both sides, you get r equals plus or minus 1 over root 2, which is equal to plus or minus root 2 over 2. So that's your r value at theta equals pi over 6. So this one up here, what I'm saying is, this is root 2 over 2 comma pi over 6. But then if it were negative root 2 over 2 of pi over 6, I would be down here, right? But that would also be, because we know that there are many ways of representing those points in polar, it would also be positive root 2 over 2, comma, what? 7 pi over 6. right? Is this guy right there. And so we can kind of see what's going on. So really I know that this is going to be, if we wanted to keep the r positive, it would be root 2 over 2 pi over 6, root 2 over 2 5 pi over 6, root 2 over 2 7 pi over 6, and root 2 over 2 either negative pi over 6 or 11 pi over 6 as the polar coordinates for that. Let's look at what Rogowski has for that. Oh, Rogowski, Rogowski, Rogowski. Where are we at? Polar coordinates, and here we go, slope. What number is this? 39. 39. Okay, his is very long. He has these following points. These 4 points. He has root 2 over 2 comma pi over 6, negative root 2 over 2 comma pi over 6, root 2 over 2 comma negative pi over 6, and negative root 2 over 2 comma negative pi over 6. And then he says, if desired, we can change the second and fourth points to positive r's by adding pi. So then he has root 2 over 2 comma pi over 6, root 2 over 2 comma 7 pi over 6, root 2 over 2 comma 5 pi over 6, and root 2 over 2 comma negative pi over 6, or that would be the same as 11 pi over 6. So those are the 4 that I said as well. So, that was easy. That was easy. No, but honestly, you have to know, first of all, the formula. And then you have to deal with the whole r squared instead of just r business. And then you have the more complicated dr d theta because you had to take the plus or minus square root of each side. And then you have the dealing with the trig functions and the double angle formulas and stuff like that, and then solving and then verifying, and that was a pain. That was a big time pain. If you were able to follow that, not get it yourself, I don't really, I feel like only like a few of you would be able to like stick with it and get it themselves. But if you're able to follow what I just did, for the most part, good on you. There would never be anything this complicated on the AP exam. However, it is good to go through and see, hey, we can do this, but they're not going to expect you to spend this much time on any one problem. You dig? They're just going to verify that you know the formula and you can apply it properly or appropriately. Okay? Cool. I need to move on because I need to teach you area today. So let's do that.